Hello there, AP Environmental Science class. All right, moving on now to chapter 13. In this chapter, we are going to talk about water resources. This chapter, once again, has about 60, I think it was 62 or 63 slides. So I will be doing this chapter in two parts, all right, about 30 slides in the first part and about 30 slides or so in the second part, all right? So again, chapter 13, water resources, will be done in two parts. All right, here we go. So first off, we talk about a core case study. This is about the Colorado River and its story. Well, the Colorado River flows through over 2,000 kilometers through 7 U.S. states in the western part of the United States. The entire river includes 14 dams and reservoirs. We're going to talk in this chapter how dams are good, but also are bad for the environment. Water is supplied mostly from snowmelt off of the Rocky Mountains. That's where most of the water for the Colorado River comes from. The Colorado River supplies water and electricity for about 40 million people, especially in the cities of Las Vegas, Phoenix, Los Angeles, and San Diego. In addition, the Colorado River helps irrigate crops that help feed America. However, there have been issues with the Colorado River. Very little water is now reaching the Gulf of California. So that's where the Colorado River ends. It ends at the Gulf of California, which is actually part of Mexico. If you know, we got the peninsula, the Baja Peninsula of Mexico, and the main part of Mexico, that little inlet of water there is the Gulf of California. Colorado River flows into it, but very little water is now reaching it because of all the damming and because of the fact that that water is pulled out to not only irrigate crops, but to supply drinking water to those cities that I told you about on the previous slide. The system, the entire Colorado system, river system, has experienced severe drought since 1999, and Lake Mead, which is part of the Colorado River, has actually fallen to record low water levels in 2015. And that's what we're really going to talk about in this chapter. We're going to talk about our freshwater resources and how, while water is a renewable resource, unfortunately, we're using the water too quickly and not allowing it to have enough time to replenish itself. And as a result, we are dealing with some issues in parts of the world not having enough fresh water. So here is the Colorado River Basin. Again, the Colorado River flows from up here in Colorado all the way down through Arizona, Utah, Nevada, California, Arizona, and then eventually ends here in the Gulf of California. So again, this is the basin we're talking about. Again, you got dams, you got aqueducts, et cetera, in this Colorado River Basin. So, will we have enough usable water? So fresh water, one of the Earth's most important forms of natural capital. I would argue without fresh water, probably not going to be dealing with much in the way of life on this planet. So again, a very important part of Earth's natural capital is this fresh water. Unfortunately, though, it is used inefficiently and it is being polluted. Low cost of water encourages waste. And unfortunately, fresh water is not accessible to many people. Again, we have a lot of people on this planet who actually do not have access to fresh water. We here in the United States, especially in Ardsley and Westchester County, it's unthinkable to not have fresh water coming into your home. But again, in many parts of the world, that's actually the case. So fresh water is an irreplaceable resource that we are managing poorly. So access to fresh water is going to be is a global health issue. Over 4,000 people die each day from lack of access to safe drinking water. Again, not so much in this country, but if you look around the world, those are the numbers. Economic issues. Water is vital for producing food and energy. So if you don't have fresh water, it's hard to produce food and it's hard to produce energy, and that could cause economic issues in the society that you happen to be living in. It's a national and global security issue because once the water becomes depleted, we're going to be or depleted, we're going to be fighting over it, right? So that becomes a security issue around the world, and obviously an environmental issue as well, as we are having excessive withdrawal of this fresh water from our aquifers, from our streams, from our rivers, our reservoirs. And again, we'll talk more about that as we go through this lecture. So most of Earth's fresh water is actually not available to us. This is the hard part to wrap our head around, but actually only 0.024% of the water supply is available fresh water for humans to use. Think about that, okay? 0.024%. So that's not 0.024, we make that 2.4%. No, this is 0.024%. We've actually already made it into a percent. That's the percentage of the water supply that is available as fresh water for us to use in groundwater, lakes, rivers, and streams. Okay, so keeping that in mind, we have the hydrologic cycle, which I know you learned about multiple times throughout your schooling. We used to call it the water cycle, then we turned it into the hydrologic cycle, and that's basically the movement of water in the seas, land, and air. But unfortunately, it is distributed unevenly around the Earth, and I think you learned that in Earth science as well. Certain parts of the Earth are deserts or are very dry. Certain parts of the Earth are very wet. We're actually learning that a little bit in this class as well. So again, that water is distributed unevenly around the globe. Humans also alter the hydrologic cycle. We do that by withdrawing and polluting water, and we do that by causing climate change, which causes the hydrologic cycle to change in particular areas, and that could bring excess rain to an area that doesn't want excess rain, or it could bring excess dryness to an area that doesn't want drought. So again, we are altering this hydrologic cycle. What are we looking at here? We're looking at ladies who are actually carrying on their pots. That's water that they're carrying in the pots on their head. Obviously, this is the Sahara Desert, and you can tell how it's very dry there. Again, so these women need to bring in water from somewhere, and they do that again by using these pots with the water, and then they bounce them on their heads and they walk back to their villages. All right, so in order to begin to understand this water resource issue, we need to understand a couple of terms. So groundwater and surface water are critical resources. So a couple of terms you need to know, and again, maybe brings you back to your earth science days. First is known as the zone of saturation. The zone of saturation, basically in that zone, you are saturated. So spaces in the soil below a certain depth are filled with water. So if you're in the zone of saturation, all the pore space between the soil, and right, we looked at soil a couple of units ago, all right? Now we're talking about that porosity, that pore space. If it's all filled with water, we consider the soil to be saturated, and that is your zone of saturation. The water table is the top of the zone of saturation, right? So if everything below is saturated with water, all the pore space in the soil, if the soil above here is not saturated with water, well, then that line is called the water table, and that is the top of that zone of saturation. What is an aquifer? An aquifer are recharged naturally by precipitation or by nearby lakes, rivers, and streams. Aquifers are basically underground water storage area. It's where groundwater is stored underground, and again, they are recharged naturally by either precip, rain or snow, infiltrating the ground, or nearby lakes, rivers, and streams that then go into the groundwater that then flow into these aquifers that again are reservoirs under the ground that store fresh water. So what is surface water? Well, surface water is surface runoff. Again, when it rains or snows, that water that is running away, we consider surface runoff. And a watershed or a drainage basin also has to do with surface water in certain areas. Basically, all the water will drain into one river. So, for instance, here in Ardsley, all the rain or snow that falls into Ardsley eventually flows into the Sawmill River. Where I live in Rockland County, all the rain or snow that falls in my town actually falls into the Ramapo River, which then goes down into New Jersey and eventually goes into the Passaic River. So, again, depending on what river is near you, that is your watershed, which again means any drop of precipitation that falls will flow into that particular river, that drainage basin, whatever it happens to be. All right, so what are we looking at here? Again, just basically, this is the hydrologic cycle, right? We have evaporation, transpiration, all right? Remember, that's evaporation of water off of leaves, all right? Leaves of plants and things like that. We have runoff, right? We have infiltration, which is water getting into the ground. We have a confined aquifer. That means you have it's dirt on either side or something that's holding the water in place on either side of the aquifer. An unconfined aquifer means coming right up to the surface. All right, you can see right here, for instance, this lake is part of this unconfined aquifer. Again, there's your water table, right? The top of that zone of saturation. So this would be the water table right here. And again, we have these aquifers, precipitation, etc. So definitely understand the hydrologic cycle and understand, even though I'm sure you do, all about the evaporation, condensation, precipitation, infiltration, etc. Okay, so we are using increasing amounts of the world's reliable runoff. So 2/3 of surface runoff is lost to seasonal floods. Right. So unfortunately, what does that mean? That means that over 66% of the surface water that is running off, we're not collecting and using for drinking or irrigating. It's basically lost to seasonal floods, right? Gets into the big river, then the river washes all that water down to a lake or to an ocean eventually, and it's actually not being trapped, that runoff to be used by humans. Again, 66% of it is being lost. So what is reliable runoff? Reliable runoff is the remaining 1/3, right, of that surface runoff we call a reliable source of fresh water, right? So 1/3 of that surface runoff we use. It's a reliable source, and we could call that reliable runoff. So here are some worldwide averages for you. Irrigation for crops and livestock use about 70%. Okay, of the reliable fresh water. Industrial use, about 20%. And cities and residences, so basically us, we use about 10%. So obviously, and we just talked about this in the previous chapter with the food production, right? Where is most of that water going? To irrigate crops or for livestock to drink, right? In those industrialized agriculture and those industrialized meat farms that we're talking about. Cities and residents only use about 10% of that water. We also now need to talk about something called virtual water. Virtual water is water that is used to produce food and other products. So what we're looking at here is basically one bathtub is worth 40 gallons of water. So it takes just under a bathtub to produce the coffee that actually you use, the coffee beans that you use to make yourself coffee in the morning. That bread actually uses 4 tubs of virtual water. So what's that? 160 gallons of virtual water to create bread. Look at the hamburger, right? That meat that we like to eat. 12 tubs of water, virtual water, to produce that one hamburger. Jeans, it takes 72 tubs of virtual water, which means you need the water to produce other things that then eventually produce the jeans. So I'm not saying that 72 tubs of water go in to produce jeans, but to produce the things that you need to eventually make the jeans, as you go through it, the process, it takes 72 tubs of virtual water. Look at that car, 2,600. Look at a house, over 16,000 tubs of virtual water. So again, when we talk about using water, we're not just talking about irrigating crops or using it to drink or things like that. We're using water for all these industrialized uses to make bread and hamburgers and shirts and cars and houses. We're using virtual water. And as a result, this is why, again, we are using increasing amounts of that water. And that's why we are dealing with some water issues and freshwater shortages in many parts of the world. So here's a core case study talking about freshwater resources in the United States. So now we have more than enough renewable fresh water. The problem is it's unevenly distributed and polluted. So there actually is enough renewable fresh water on the planet for everybody. It's just not evenly distributed, and in many places it's polluted, and that's why many people do not have access to it. So what we're looking at here are, again, this is the United States, so this isn't the world as a whole. On the left, we're looking at how the U.S. uses its fresh water. So there we go, electric power plant cooling. Think about that. So this is to produce electricity, to cool the power plants. That's where 41% of the United States is using its fresh water. Irrigation, there you go, crops, 37%. Public water supply 13, industry 5, livestock production 4. On the right-hand side are how normal people like you and I use water. All right. So you'll notice toilets, flushing toilets, 27%. That's why it's always said don't flush the toilet unless you really have to. Right. Look at leaks. 14%. That's a waste. We'll talk about that a little bit more later on in this lecture. But if we can just fix the leaks that we have, we'll save 14% of the fresh water, right? And that faucets are wasteful. They're not efficient. So we're losing 15% there. Showers, 17%, right? Washing clothes, 22% of the fresh water. So again, we can see here the breakdown in the U.S. And again, look at that leaks, right? If we can deal with the leaks, or again, look at the irrigation, right? If we can start, going back to that low impact polyculture farming, right? Not the high industrialized, the high input, the low input. We might be able to reduce some of that irrigation percentage as well. So again, ways we're using fresh water, we need to look at ways where we can reduce our use and try to conserve more of that water. Because what's going to happen is we're going to end up having water scarcity hotspots, which could potentially cause conflict, obviously, right? So here are just an idea where it's red, you could have high conflict with people looking for fresh water, right? Here you have unmet rural water needs in parts of Arizona. So again, this is the issue. Like, I don't expect people in Colorado and Utah to start fighting each other over water. But when you talk about security, you could have countries and other cultures potentially fighting each other down the road for water resources. And that's something we don't want to get to here on the planet, right? We got enough problems, got enough people fighting on this planet. The last thing we need is people fighting over fresh water. So again, this is where you come into play as the next group of folks heading out there. Again, we need to figure out ways to conserve this fresh water. All right, so critical concept, your water footprint. So remember at the beginning of this course, we looked at our carbon footprint. Now we're talking about our water footprint. That's a rough measure of all the water an individual uses. And again, we talk about this virtual water once again. Virtual water is water used indirectly to produce products and food, but is considered part of a person's water footprint depending on what they consume. So again, this is, we just looked at this before, but again, more of that virtual water. So again, if you're someone like myself who eats a lot of meat, there you go, right? We're using a lot more virtual water than, let's say, someone who eats a lot of vegetables. So again, this is some of the things we need to think about when we talk about our water footprint, because freshwater shortages are unfortunately just going to grow because of the issues we've talked about previously. Many of the world's major river systems are highly stressed. That's the Nile River, the Jordan, the Yangtze, and the Ganges River, right? More than 30 countries face freshwater scarcity. Estimate 60 countries may be facing freshwater scarcity by 2050. 30% of Earth's land areas experiencing severe drought, and research predicts this will worsen with climate change. So again, that other 70% not dealing with drought, but again, the water is distributed unevenly, so 30% of land areas are experiencing that drought, and again, with climate change, we're thinking that may actually increase. So what are we looking at here? Freshwater shortages. This is now around the world, and you'll notice where the red is where you're in high stress. So most of the western part of the U.S., high stress. Look at Northern Africa, high stress. Look at the Middle East, high stress water, right? And these are areas where there is conflict, unfortunately. So again, unfortunately, this water scarcity may increase the conflicts in these areas, and that's where we need to come in, or you guys need to come in and figure out ways, if you are going to get into some kind of environmental sustainability job, figure out ways to reduce that freshwater use so we don't have these freshwater shortages. We don't have stress on certain populations and on certain cultures. So, is groundwater a sustainable resource? Well, groundwater is used to supply cities and grow food, is being pumped away from many aquifers faster than it is being replenished by precipitation. So, in essence, groundwater is a sustainable resource, right? Because the water cycle will eventually bring that water back in the form of precipitation, right? Either rain or snow. The problem is we're pumping water out of the aquifers quicker than the aquifers are being replenished by the precipitation. So, unfortunately, our use of groundwater is causing it to become an unsustainable resource, even though it should be a sustainable resource, because in our lifetime, it will definitely replenish itself. The problem is we're using it too quickly, and that's what we need to try to figure out, how to slow down our use of the fresh water so that the fresh water, the groundwater, can be sustained by the natural capital of the earth, meaning the hydrologic cycle, right? So again, groundwater withdrawals are unsustainable in some areas. This is the problem. Aquifers are renewable resources for fresh water unless they are contaminated, meaning getting polluted. But widespread drilling of wells by farmers has accelerated aquifer overpumping, and this has caused the water tables to fall, right? What is the water table? The top of that zone of saturation. So as water tables are falling, that's because that zone of saturation is getting smaller because you're pumping the water out of the ground, right? And in fact, in 2008, Saudi Arabia announced it has depleted already its major deep aquifer, which means it's going to take years and years for it to replenish itself naturally, because again, you're not getting a lot of rain in Saudi Arabia as it is, right? So now you got an area that's a desert, you depleted its aquifer, it's going to take a long time for that aquifer to fill back up. So here are your trade-offs withdrawing groundwater. Again, advantages and disadvantages. Definitely understand these. Advantages: useful for drinking and irrigation, exists almost everywhere, groundwater, renewable if not overpumped or contaminated, and is cheaper to extract than most surface waters. Disadvantages: aquifer depletion from overpumping, right? Taking too much water out. Sinking of land subsidence from overpumping. I'm going to show you an incredible picture coming up in just a second. Some deeper aquifers are non-renewable because when you go very deep into the ground, it does take a very long time for water to infiltrate down there, so they may not be replenishable in our lifetime. And the pollution of aquifers can last decades or centuries because they are so far into the ground. So once you pollute an aquifer, it's very difficult and takes a very long time for that aquifer to clean itself up. So a core case study is something overpumping of the Ogallala aquifer. This is one of the largest known aquifers. It's underneath a large portion of the southern part of the United States. It irrigates the Great Plains. It unfortunately has a very slow recharge, and the water table is dropping. Water is being pumped 10 to 40 times faster out of the Ogallala aquifer than it is being recharged, or then faster than its recharge rate. So again, this is not sustainable because we are pumping water out faster than it is being replenished. Government FARB subsidies result in further depletion, right? And the biodiversity is being threatened in some areas because of the overpumping of this aquifer. So you'll notice here is where much of this aquifer is located, right? Southern and central parts of the U.S. And again, here is where you have groundwater overdrafts, meaning you're pumping too much water out of the aquifer in these areas, and that is, of course, leading to issues. So what type of issues? Well, let's talk about it. Overpumping aquifers can have harmful effects. So number one, it limits food production and raises prices. When you don't have enough water to irrigate your crops, that's going to reduce the food yield, and therefore food prices are going to go up because there's less food and more demand. This will then widen the gap between the rich and the poor. You also have land subsidence. This is when the land actually falls or subsides. So the San Joaquin Valley in California, this has happened to. I'm going to show you that picture in a second, I promise. In Mexico City, it is also happening. Groundwater overdrafts near coastal regions have another issue. So if you have an aquifer that is near a coastline, if you deplete or you overdraft or pull out too much water, you allow salt water then to come in, right? You have this aquifer that's nice and filled, keeping the salt water out. Now you deplete the aquifer, it doesn't get replenished. That allows salt water from the neighboring ocean to come into your freshwater aquifer. And guess what? The minute salt water enters an aquifer, it is useless. You cannot use that aquifer again because the water now is not fresh water, it's salt water, and it takes forever for that to fix itself underground. Because again, you have a very slow recharge rate, right? Infiltration takes a long time to get that rain and snow back into the aquifer. So if you have a groundwater overdrafts near coastal regions, you can contaminate the groundwater, that aquifer, with salt water, and then you're done. Then that aquifer is useless again. So just some other issues. Here is this incredible picture I wanted to show you. Guys, this is not a joke, okay? This is in the San Joaquin Valley of California. They've been pumping water out of their aquifer from 1925 to 1977. The land, so where this guy is, the land in 1925 was actually up here on this pole. Think about that. Okay? Because they pumped too much water out of the aquifer, the ground subsided or sunk. Here is now ground level 1977. The ground sunk this much because, unfortunately, too much water was pumped out of the aquifer under the San Joaquin Valley in California. It was pumped out too quick. It wasn't allowed to replenish. And so the ground subsided or sunk into that aquifer. And look how much subsidence occurred here. Incredible. In just over, 50 years. That's an incredible picture. All right, so here are some solutions to groundwater depletion. Prevention and control, once again, know some of these, all right? Prevention, use water more efficiently. Subsidize water conservation. Limit the number of wells a person can have, and stop growing water-intensive crops in dry areas. How can you control? Raise the price of water to discourage waste. Tax water pumped from wells near surface water. So if you're going to pump water from a well, you got surface water, you can get that. If you're going to pump it, we're going to tax you. Build rain gardens in urban areas and use permeable paving material on streets, sidewalks, and driveways. Why permeable? Because that allows more water to infiltrate the ground and sink into those aquifers, into that groundwater, hopefully recharging those aquifers. All right, so how can we increase freshwater supplies? Obviously, that's going to be we're going to have to find a solution here as we go through the 21st century here. So large dam and reservoir systems can increase fresh water. They can greatly expand water supplies in some areas, but large dam and reservoir systems also disrupt ecosystems and displace people. So once again, when we talk about dams, they are good, but they are also bad for the environment, and we're going to talk more about that over now these next 6 slides. So large dams provide benefits and create problems. So what is the main goal of a dam and a reservoir system? Right? To capture and store runoff. That's the whole idea, right? We have this surface runoff. It runs off into streams. Instead of the streams taking the floods, right, 2/3 of that water away, the dam reservoir system will capture and store that runoff. And then we can release the runoff as we see fit. So for flood control, maybe we're going to generate electricity, maybe we're going to supply irrigation water, or maybe we're going to use that runoff for recreation, right? Many of our reservoirs you can swim in, you can boat on, sail on, things like that. All right, so what are reservoirs? They increase the reliable runoff available for use in an area. But again, they displace people because when you create a reservoir, you're damming a river. That river then kind of floods the area behind the dam. So if you were living next to the river, they dam the river, right? The river then begins to flood the area, you're going to have to move. It impairs the ecological services of the river because actually running water purifies water. So now you're stopping that water from running, so that can impair the ecological services. You can endanger plant and animal species, right? Because think about it, certain species don't want to live in a lake. They want to live in a river, right? So now you dam up the river and you turn it into a lake, and that unfortunately can affect those species living there. And in addition, fill up with sediment within 50 years, you still got the river coming into now this lake or this reservoir that you created. Well, all that sediment is still coming down the river, filling up the reservoir. So eventually you're going to have to dredge the reservoir at some point. All right, Oroville Dam in California was compromised by extremely heavy rainfall after a severe drought. So this is another issue with dams. So this happened, and the main spillway which damaged, which almost caused the weir to collapse, which is basically what's holding back the water. And 180,000 people were evacuated with only an hour's notice because we thought this dam was going to be breached. So again, here are 2 images of the Oroville Dam before and during the spillway failure in February 2017 when severe rain and snowmelt require the use of the spillways to prevent the dam from overtopping. So again, these are some issues that you can have with these dams, right? Because what happens eventually, sometimes you get too much rain or snow, and that could cause the dam to overflow, and so you got to let water out the spillway. Well, now you unfortunately have flooding downstream, and that could displace even more people. So again, large dams provide benefits, create problems. So you'll notice, what are we looking here? On the left-hand side in the green are the benefits of dams. Provides irrigation water above and below the dam, provides water for drinking, reservoir for recreation, can produce cheap electricity, hydropower, right? Can reduce downstream flooding for cities and farms. The problem is, the flooded land destroys forest and cropland and displaces people. Large losses of water through evaporation now, because now you got this large lake. Well, it's water's being evaporated. Deprives downstream cropland and estuaries of nutrient-rich silt, right? Because all the silt now, that soil is being held here in the reservoir, doesn't get through the dam to the downstream areas. So now they are not getting the nutrient-rich silt that they may need. Risk of failure and would cause devastating downstream flooding if the dam fails. And it disrupts the migration and spawning of some fish. For instance, salmon, right? Salmon, you may or may not know, right? They spawn in the same little ponds every year or every couple of years. Whenever it's their turn to mate, they come up the river, right? Well, now if you got a dam in the river, how can the salmon get to its spawning ground, right? So again, these are issues that dams do create for us. In addition, climate change can intensify weather extremes. So with dams, mountain snowpack will be reduced, making less fresh water available downstream. When water levels drop, hydroelectric dams cannot function, meaning they can't produce the electricity, right? So now you got this dam, you want it to produce electricity, it can't because of climate change. And for instance, the Colorado River will most likely not be able to meet the water needs in Arizona, New Mexico, and California as we go down the road, again, because of all these issues that we've spoken about. All right, so that concludes part 1 of my lecture on Chapter 13, Water Resources. Tune back in for Part 2, and as always, thanks for listening.